All right, we're on to our next station, measures of variation. Variation basically means how much something changes. So that's how we measure if there's a very wide spread of data or if all the data is close together. So number one, it says a measure of variation is a measure that describes the, oops, I hit the wrong button, the spread of data. Three measures of variation are MAD, IQR, and range. Now I'm going to go through this video rather quickly, so if you need to pause at any point, go for it. This is going to be your how to do all of these things sheet that you're going to refer to, but make sure you're listening too. So the measures of variation are MAD. MAD stands for mean absolute deviation. IQR stands for the interquartile range, and range, which you already know how to find. So let's start with range. First, I'm going to talk to you about what it tells us, and then we'll do how to find it. So the range tells us how spread out the smallest value and the greatest value are in the data set. Okay, I read that differently than what it says on the paper. How spread out the smallest value and the greatest value in the data set are. That's what it tells us. Just tells us, like for example, if I give you a test, and the lowest test grade was a 15% and the highest test grade was a 100%, that's a fairly wide range of data. If I gave the same test in another class and the smallest data set was 60 and the largest data set was 80, the range is only 20, and that's not a very great variation. So that means most kids are at the same point. Okay, so to find the range of set of data, identify the greatest value and the least value. That's all you have to do is just identify them. Usually you subtract them too. Okay, this is a new thing for you, interquartile range. So you need this to draw your box and whisker plots. And I think you've already drawn your box and whisker plots, so this should be pretty easy for you. The interquartile range represents the range of the middle half of the data. So when you draw your box and whisker plots, it's the box. It's the smallest number in the box compared to the largest number in the box. That's the interquartile range. So this is how we do it. You find the median of the entire data set. That's quartile 2. Then you find the median of the lower half of the data set. That is quartile 1. Again, if you have to pause at any point, feel free. I just want to keep on moving. Then find the median of the upper half of the data set. This is quartile 3. Then all you do is subtract quartile 1 and quartile 3. You always want a positive number, so we're really just looking for the distance there. Now I'm going to go on to the next page, but feel free to pause this and make sure you get everything written down. When you get done with this video, you are going to refer back to these steps so that you can do this on your own. Okay, mean absolute deviation. Mean absolute deviation is like how far away things are from the mean. So we always want to know, okay, suppose you got a 15% on your test. How far away were you from the average test score? Let's suppose the average test score was a 65. You're pretty far away from it. In the reverse, if you had a 95 and the average test score was 55, then it's a positive. But it's still far away from the average, like you did really well compared to the average. So the MAD shows how close or how far away the numbers in a data set are away from the mean. Do you remember years ago they used to wear shirts that say, "Are you mad, bro?" This is kind of like crazy data. Like, how crazy is the data? Number one, you have to find the mean of the entire data set. Number two, then find the difference between each data value and the mean. Now, I want you to write something else in here. I want you to write the distance. And I'm going to pause the video so I can get my writing tools. So we're going to try a practice problem together right now. And it says find the range, the interquartile range, and the MAD of the data set below. Round your answer to the nearest tenth if necessary. This is a nice set of data because if you look at it, they're all like round numbers, multiples of 10, and they're already listed in order for us. So to find the range, we take the largest number and subtract the lowest number. In this case, the range is 80. Now the interquartile range. We know if we were to make a box and whisker plot, this is our median, correct? So that means we are going to take these three numbers and find the median here, which in this case is 20. We'll take these three numbers and find the median, and that's 80. So the interquartile range is 80 minus 20, and that's 60. Okay, now the hard part's coming up. Pause the video because I'm going to need to clear the screen here. All right, here we go. The MAD. This takes a bit of time. The first thing we need to do is find the mean of all of the data. Now this is kind of nice. I don't know if you noticed this, but what's 10 plus 90? 100. What's 20 plus 80? 100. What's 40 plus 60? 100. So we have 3 hundreds here, and now we have to add 50. So this is why the data is so nice. So we have 350 to find the mean. Don't forget, we're trying to find the mean first. So to find the mean, we're going to take 1, 2, 3, 4, 5, 6, 7. We're going to divide 350 by the 7 pieces of data. So the mean is 50. Now for each one of these pieces of data, we want to find the difference between the piece of data and 50. So we have 50 minus 10. We have 50 minus 20. All I'm doing is listing these pieces of data here. I have 50 minus 40. I have 50, minus 50. Now I have to do, and I'll just draw this line here so don't forget. So and then I have to do, remember we're looking for distance, so we don't care about the negative values, we just want to know the difference between the two numbers. So now I'm going to start with 60 minus 50, 80 minus 50, and then I'll do 90 minus 50. We're just looking for the differences. So I have a 40, I have 30, 10, 0, 10, 30, and 40. I know this is a lot of writing here. So now I have to take all of these bits of data and add them up. So I have a 40, a 30, and a 10. I bet you I can do that right in my head. 10 plus 30 is 40. 40 plus 40 is 80. So for these pieces of data, the total is 80. Now over here I have a 40, another 10, and another 30. Same bits of data. So 40 plus 30 is 70, plus 10 is 80. So I have 160. There are still 7 pieces of data. So the MAD is 160 divided by 7. Please grab your calculators for me and divide that out. I'm going to do it up here. 160 divided by 7. I'm going to bring down my 0. Or actually, let's leave it as a fraction, 22 and 6/7. So the average variation for MAD is 22 and 6/7. So each piece of data is about almost 23 away from the mean.
At this time, all students can transition to period 2. At this time, all students can transition to period 2.
You can tell I'm making this period 1. Okay, good luck with this. Use this sheet.